Did you put in contacts?
What?
Did you put in contacts, did you say?
No, I had to put eye drops in
Okay.
because I cut my cornea this weekend.
Oh, did you?
So, can you see it? Where it's all red?
Yeah, I can see it's red, yeah.
Yeah, it's bad. It's not that bad. I can still see, but.
Well, use hand sanitizer. There's some up there if you need. And you got to take off that sweatshirt. It's not uniform. Oh, you too, Caleb.
Sorry, buddy.
I didn't see you. Caleb, your sweatshirt is not uniform either.
What?
Your sweatshirt is not uniform either.
Oh.
Sorry. It's not that bad today.
No. But some teachers are like, you're not allowed to use a Newman sweatshirt. They're like, it has to be a Newman sweatshirt, but technically it's a Newman
It has to be a uniform.
I know. I'm not saying you're doing it. I'm just saying some teachers are like a Newman sweatshirt with the right logo.
Oh.
But our shirts and this.
They don't want us. They're trying to make it so that it's all uniform. Because then if only one teacher like enforces it, then all the parents like complain to that one teacher. The principal wants us all to be uniform, and she gets mad at us if we don't enforce it. If you guys would take a look at the not the MyOpen Math, this is on Google Classroom. We'll go through some of these together so that you see what you're doing. These are due, I think I put them like Thursday at noon, so you've got the next 2 class periods to work on this in here.
This Thursday or next Thursday?
This Thursday. They're not too bad. It's like a little trick you sort of memorize. So if you guys would get onto the classroom.
You got to do the class.
The class?
You need a piece of paper. Classroom today.
All right.
What's up? You need a piece of paper. Who needs paper? Anybody need paper? Today you're just opening the assignments. You got paper? You're just doing this on paper and you're taking pictures and sending them. You need paper now?
Oh, yeah.
Give you the paper. We're trying to cut down on.
This new day.
No, both of these are due Thursday at noon, so you guys can have a couple, today and Wednesday to work on it in class, or you can work on it at home. There are videos that go along with this, but I was gonna walk through this with you guys so that you saw how to do it. I don't think it's very hard, hopefully you agree. And it just kind of wraps up our solving equations for the unit. So we will be having a test coming up over the last assignments that we've had, the solving equations, the linear relationships, and then the stuff that we're doing today. So those things will be a test, or the topics of the next test.
All right, we're going to start with the determinants. I don't think we got to this last year, but we're going to do it earlier this year. Make sure we get to it. So you can go ahead and go to the determinants one. Here's a couple of videos that go along with it if you were doing this at home. But otherwise, this link should take you to the worksheet. And again, you've got the answers to check your work on the back page. But I'll just show you how you can take a determinant. It's going to seem a little weird at first because you're not going to know why you're doing this at first. I just kind of want you to learn the process of doing these sorts of things. And then as we go forward, you'll start to see the applications of this. So like on the second worksheet, you'll see how we can use these. But for now, it's just a little algorithm you're going to learn, and we'll explain it later. So the first one, I'm going to try to write this out for you. So what we have is these are matrices, and they're very useful in a lot of different fields of mathematics, and they're extremely useful in science and engineering, pretty much everything. It's a very important thing in math. Now, there are 2x2 matrices. They get as big as you need them to get. But, I mean, I guess they get pretty small too, but usually the smallest ones we usually look at are 2x2 when we're starting out. What that means is something like 1, 2, 3, 4. And a matrix is just an ordered arrangement of points, or I'm sorry, numbers. So this is like it's basically a data structure, just like an ordered pair, like your x, y points. That's an ordered set of numbers. It's not a single number, it's a pair of numbers. So your x, y points that represent where something is on a grid, that's kind of like this, in that it's not just one number, it's got multiple numbers. Well, a matrix is similar. It's an ordered array of numbers here. So this represents a matrix, and there's a lot of stuff that matrices can represent, and a lot of things that matrices can do. So there are some matrices that represent rotations. A camera can be represented by a matrix. So like if you think of this room with all the people in it, and you think of like all the coordinates that represent where your eye is, where your ear is, where your nose is, you can represent where all the parts of you are with coordinates. And then there, you could imagine there's a matrix that takes a 3D world and turns it into a 2D projection, like a picture. And so we can actually describe the way a 3D scene gets flattened into like a 2D picture. Like if you took a picture of the room and you got a little, you took a picture on a sheet, the way a 3D geometry gets flattened onto a 2D sheet can be represented with a matrix. So these are very powerful and useful. I know that sounds complicated, but right now we're just learning some basic stuff with a matrix. This is a 2x2 matrix. We always put the rows and then the columns. So there's 2 rows and then there's 2 columns. So we'd call that a 2x2 matrix. This would be a 2x1 because it has 2 rows but 1 column. I don't know if you remember that pop, RC Cola. It always goes R then C, rows then columns. So I don't know if that helps you remember which one goes first. Hope that helps. But this is, so that's a 2x2 matrix on the left. Here's a 3x3. I don't know. I'm sorry, did I say 3x3? Yeah, that's a 3x3 matrix. I think most of the ones that you have on your first sheet are 3x3s, but I'll show you the 2x2 version as well. I'm not going to get too much into what a determinant is just yet, but we will just start by learning how to calculate the determinant of a matrix. So here's a simple matrix. This will be 1. I'll just do 1, 2, 3, 4. And that's a 2x2 matrix. If I wanted to calculate what's called the determinant of the matrix, which we'll get into what that is. You can kind of think of it as the size, maybe, a little bit like that, maybe like the absolute value. That's not really the best description, but I'll explain it later. But I wanted to go over how do you calculate the determinant of a matrix. So this is a matrix, and you can see it's represented, I usually represent them with parentheses. You could easily see it represented like this, with square brackets. That's, I think, how it is on your worksheet. But when you write it like this, with straight up and down bars, this represents the determinant. The determinant of the matrix. And they're pretty straight, they're really easy to calculate when you have a 2x2 matrix. All you have to do is take the diagonal going this way, and then there's another diagonal going the other way. Maybe I shouldn't have chosen similar colors. This diagonal, you have 1 and 4. So 1 times 4, these ones are, this is a positive term, the one that goes down this way. This is 1 times 4, and it's positive. And then you'll subtract the one that goes the other way. This is 2 times 3, so that'd be 6, and you subtract it. So that comes out to be 8. So that would be the determinant of that matrix. And that's all you do for the 2x2s. Does that seem okay? Yeah.
Can you explain that again? Would you just write down 1 times 4?
Yeah, 1 times 4. Oh, yeah, I'm sorry. I did 14.
Yeah,
Yeah, sorry. I wasn't thinking clearly. 1 times 4 is just 4, right? I was thinking of that as 14. So 1 times 4. And then 2 times 3 is 6. So it should be 4 minus 6. That was wrong. Negative 2. Does that make more sense now?
Yeah.
Sorry about that. We'll do another one. 6, 2, 3, 5. Oops, what I should do is do the straight up and down to show that what I want is the determinant of the matrix. So what would I do in this case? Yeah.
6 times 5.
6 times 5, and then 3 times 2. The other way will be subtracted. Right?
Yeah.
So 30 minus 6. What does that give me? Good. Is that easy? All right, we'll do one more of the 2 by 2s because on the second sheet you'll have some 3 by 3s and some 2 by 2s. I'll do a different color still. About minus 1, minus 2, 6, and 0. What would I do for this one? Anybody?
Be 0 minus negative 12.
Yeah, 0 minus negative 12. Does everybody get that? Minus and negative makes it a positive 12. Good. Are you good on that? All right, so we're going to scale up to the slightly harder ones. Those are the 3 by 3s. We'll do the first one on our paper here. We're going to do it 2 different ways. 3 minus 2, 1, 3 minus 1, minus 2, 3 minus 2, minus 2. And we want to find this determinant. There's numerous ways you can kind of find determinants of larger matrices. We'll go into some of those other ways later. I'm going to show you a kind of trick that helps you on the 3 by 3s. That will, I think it's pretty straightforward, but it does take a little bit of getting used to. So what you do to do the 3 by 3 is you have to extend the numbers. So I will extend them with this light green, I guess. So once I did this column, and then this column, I need 2 more columns, so I'm going to repeat the first and the second column to the right. So I'm going to say 3, 3, 3, and then minus 2, minus 1, minus 2. So I've just extended the first 2 columns past the last one. Now, the trick is I will do, I don't know, I guess blue. Let me do a lighter blue. Now, do you see how this, if I do a diagonal, it's all alone. And if I do a diagonal, there's only 2 of them. But here there are 3 diagonals. So I'm able to get a diagonal there. And you'll see that I actually get 3 possible diagonals when I make this extension like that. And these are going to be the positive terms. Just like before, I am going to multiply each of those sets of 3, each of those triples, and then I'm going to add up. Those are each going to be positive contributions to the determinant. So my first one has 3, minus 1, and minus 2. if I multiply all those, I have two negatives that would make a positive. So what's 2 times 1 times 3? It is 6. So this is going to equal a positive 6. The next one, again, I've got two negatives to make a positive. So what's 2 times 2 times 3? So I have a plus 12 there. And then in the last case, I'm going to add this product, but there's one negative, so that's going to make it a negative term. 3 times negative 2.
6.
Good. So minus 6. It's really a positive term. I really add that, but because it's a negative term, it becomes subtraction. Then I have the negative terms. So I can make a diagonal here, here, and here. Now these are going to be subtracted. So my first term is 3 times negative 1 times 1. What does that give me? Negative 3, yeah. But I'm subtracting these terms. So I'm going to subtract a negative 3, which will end up being addition. This next term, because of the two negatives, will make a positive number, but I will be subtracting that because this is the left-going diagonals. So 2 times 2 times 3. Good. And then I'm going to subtract, and I have two negatives again, so that'll make a positive, so I will continue to subtract. Again, this is 2 2s and a 3, so that's another 12. And that will give you your determinant. You just have to calculate what that is now. The 6 and the 6 kind of cancel there. A 12 and a 12 kind of cancel. And I have a positive 3. Jeez. A negative 12. The heat's coming on. So 3 minus 12 is the opposite of 12 minus 3. So minus 9. Does that make sense? You guys kind of follow that? All right, I'm gonna do that one more time. I'm gonna start with my matrix that I had before. 3 minus 2, 1, 3 minus 1 minus 2, 3 minus 2 minus 2. This time, instead of taking those two columns from the first column and the second column and repeating them, I'm going to take the first and the second rows and repeat them underneath. So it's the same thing, only now I've extended the rows instead of the columns. Yeah. For this method, yeah. So this time I've taken the first and the second and I put copies of them past the third. Just like how I did with the columns, but this time it's the rows. And it's the exact same thing. So if these ones are going to be the positives. And you'll see I get a term that is 6. I get a term that is, well, yeah, that was a positive 6. This is a negative 6. And this is a positive 12. So it's the same numbers I had before for the positives. And then for the negatives, I'm going to come this way. And these two methods are equivalent. So for the negatives, I get a -3, which I had here. I get a 12, and then a 12 again. So I get all the same numbers, but I just extended it by rows instead of by columns. So it doesn't matter which way you go, which I guess that just depends on how much space you have on your paper, or which way you prefer. You can do it either way. You can either extend a couple of columns, or you can extend a couple of rows, but this is how you'll take a determinant of a three-dimensional matrix. Is that okay? So that's how you do that sheet, that first sheet. I'll let you guys maybe get that done, and all you have to do is take a picture, show that you can do it, and get credit for that. And then we'll get to the other sheet later. Yeah. Yeah.
Is there